We're going to be looking at different exponent rules. First rule we're looking at is when we are multiplying powers. Okay, as you can see, we have x to the power of 2 multiplied, right? Brackets means multiply, multiplied by x to the power of 3. Well, x to the power of 2 means x times x. What does x to the power of 3 mean? X times x times x. If I want you to write this as a single power, how many x's do we have? 5. So this would be x to the power of 5. Let's try the next one. Y to the power of 4. 1, 2, 3, 4 times y. How many y's do I have? So can I actually put an exponent of 1 here if there's no exponent? Yes, of course. Anything that doesn't have an exponent, you can imagine it's to the power of 1. You're writing it once. What is the answer to this one? And it's a single power. Y to the power of 5. Anybody notice anything about the exponents when we were doing this? When you multiply powers with the same base, this is important, they have to have the same base, okay? All you would have to do is add the exponents together. So you write the base, right? If it's the same base, you write the base, and then you add the exponents, and that's actually a shortcut. Sorry, so as an example, 4 to the power of 5 times 4 to the power of 6, we're multiplying the powers, write the base, add the exponents. What's 5 plus 6?
11.
So it becomes, as a single power, 4 to the power of 11. What about the next one?
When you add 9 plus 3 equals 12, and then you add the
Good. We have our exponent of 9 plus 3 is 12, but we have to also put an imaginary 1 there. K to the power of 1. There's an exponent of 1, not 0. It's an exponent of 1. So the total is 13. How would you write the last one? So again, the rule is write the base, Mark.
Is it 5x to the power 2?
So you write the base, which is 5, and then it's to the power of, add the exponents. X, add, plus 2. Now we're dividing powers, right? This fraction bar also means division. So I just want to show you why this rule works. Well, the numerator is x to the power of 5, so I'm going to write that 5 times. I'm going to write x 5 times. 1, 2, 3, 4, 5, divided by what? Yep.
To the power of 2.
1, 2. What happens when you divide something by itself?
You subtract.
It cancels out, right? X divided by x is just a 1. 1 times anything is still that anything, right? You're not changing the value. So I can cancel this and this out, this and this out. What am I left with?
3 x's.
I'm left with 3 x's. How do I write that as a single power?
X to the power of 3.
X to the power of 3. Notice a pattern yet?
Yes.
Let's try the other one first. 25 to the power of 4 means 25 written 4 times, divided by 25 to the power of 3. I'm writing the number 25 3 times. How many can I cancel out?
3.
1, 2, 3. What am I left with?
1.
25 to the power of 1, or I can just write 25, right? That means the same thing. Did anyone figure out the exponent rule? I had exponent of 5 and 2. The answer was 3. Here I had 4 and 3. The answer was 1. Yep. You are dividing powers with the same base. Again, it has to be the same base. All you need to do as a shortcut is subtract the exponents. So again, write the base, whatever the base of the power is, it has to be the same. And then just subtract the exponents.
No question.
Yep. Okay, first one. 3 to the power of 24 divided by 3 to the power of 6. Rule that applies. What do I do first? Write the base, which is... Good. Then you subtract 24, take away 6. What's your final answer? 3 to the power of 18. Excellent. B, the second one. X, again, write the base, subtract the exponents. 20 take away 2 is 18. What about the last one? M is the same as m to the power of 1, right? You're writing the base once. 7 take away 1 is 6, so it's m to the power of 6. The last rule is looking at something called power of a power. Everyone look here. This says, I want you to learn how to read this. I have y to the power of 2, right? All of that to the power of 5, okay? So the base here is actually y to the power of 2. It's a power within a power. So I have y to the power of 2 to the power of 5. So I'm going to write y to the power of 2 how many times? 1, 2, 3, 4, 5. Okay, so I'm multiplying y to the power of 2. I'm multiplying it by itself 5 times. Now, you have something that is multiplying powers. What do you do to simplify this? You just learned it. It was rule number 1. What do you do when you multiply powers with the same base? Good. You add the exponents. Do they have the same base? What's the base? Y. What's 2 plus 2 plus 2 plus 2 plus 2? 10. Repeated addition is the same as what? What could have been a shortcut here? I'm taking 2 and I'm adding it 5 times. 2 times 5 is 10. A to the power of 12 to the power of 2. How do I write this in expanded form? Yep.
A to the power of 12.
Good. A to the power of 12 times a to the power of 12. Same base, a, multiplying these two powers together. What do I do with the exponents? What's 12 plus 12? What is 12 times 2? So the final rule, look here. To simplify a power of a power, what's the shortcut? What do you have to do with the exponents? Multiply the exponents. Good. Based on the rule, what is 2 to the power of 3 to the power of 4 as a single power? 2 to the power of 12. All we had to do was multiply the exponents. What about the next one? The base of this one is a negative 4. Because it's inside this bracket, it's negative 4 to the power of 13 to the power of 2. What's the final answer? Negative 4 to the power of 39. Good. Okay, and make sure that you put this negative 4 inside a bracket, just like it is in the original question. And the very last one, this is easy. X to the power of 7 to the power of 4 is x to the power of 28. 7 times 4 is 28.
Made with Doodlecast Pro.